Today we're going to do something just a little bit different. Notice our directions have changed. It says solve each quadratic equation by factoring or by taking square roots. If the equation has no real number solution, write no real solution. All right, so that means both of the methods we've been practicing recently are available to us today. So we need to take a minute and talk about how do we know which method to use. So we like to use the factoring method when we have a trinomial. So if I have something that looks like ax squared plus bx plus c equals 0, I would need to use the factoring method. Now, what if c was 0 and I had ax squared plus bx equals 0? There's no number there. Well, I still need to use the factoring method, even though it's not a trinomial. I don't have to put in the middle term, but I would need to factor out a GCF. So if I'm using the factoring method and I have a traditional trinomial, I'm going to first split the middle term to factor, and then I'm going to solve using the zero product property. If instead I have one of these binomials where there's a variable in each of the terms, I'm going to factor out a GCF, and then I'll be able to solve. Now, in this case, once I've factored out a GCF, I might be able to solve by taking square roots, or I might need to solve using the zero product property. It sort of depends on what happens next. So when do we use solving by square roots? So we use solving by square roots when we have an x squared plus a number equals 0. Now there's different variations on that. It could be minus a number. There could be a number in front of x squared. So if I had some number x squared minus a number equals 0, that could be a solving by square roots. The key is that bx term is missing. That's when I want to use the method of solving by square roots. So that's what we want to keep in the back of our minds as we take a look at some of the problems on here and decide which method to use. So the first thing we're going to do is make that decision for each problem. And then we'll do some of them together and you'll do some of them on your own. All right, let's look at number 1. Notice that's got an x squared and a number, but no bx term. So this is one that would be great for solving by square roots. Let's look at number 2. Again, I have an x squared term and a number. I can probably do this one by solving by square roots, but I'm noticing something. Notice that the 5 and the 20, those have a GCF. So I'm going to be able to solve by square roots, but first I might want to take out a GCF. It's not necessarily required. So we'll do that one together today so that I can show you both options. All right, number 3 looks a little intimidating because there's a decimal in there. We'll do that one together today as well, but let's look at it. Notice it has something squared and a number, so we can solve this one by taking square roots. Let's look at the bottom row. I see a number times x squared, and I see a number, so again we can solve by taking square roots. We're 4 for 4. Now let's look at the last one. I see an x squared, but this term has an x. I cannot do this one by solving by square roots. This one is going to have to be a factoring problem. So I'll do that one with you today as well. So you already know that problems 1 and 4 are going to be your daily practice tonight. All right, let's do these 3 problems together. I mentioned that I'm going to do number 2 different ways. first, I'm going to do it straight by solving by square roots. So I'm going to take the 5x squared minus 20 equals 0, and I'm just going to get x squared alone. I'm going to add 20. So I have 5x squared equals 20. I'm going to divide by 5. So x squared equals 4. And now I can use the solving by square roots. I'm going to take the square root of each side, and x equals plus or minus 2 because 4 is a perfect square. That's probably the simplest way we could approach this problem. But what if we didn't notice and we tried something else? Well, there's other ways we could have tackled it. Maybe we noticed that they had a 5 in common, and we factored out a 5, and so we got x squared minus 4 equals 0. Well, there's two different directions we could have headed. One option is we could have continued with the idea of solving by square roots. We could have said, well, obviously 5 is not going to be equal to 0. But if x squared minus 4 is equal to 0, then we could add 4 to each side, and we would have that x squared equals 4. And if we take the square root of each side, x equals plus or minus 2. The very same answer we got before. But maybe we decided to switch over to factoring. That would also be an option. So if we decided to switch over to factoring, we might have looked at this and said, well, I can factor that further if I put in the 0x. I'm not going to go through all of the steps to get the factoring done, but if I did that, I would end up with an x plus 2 and an x minus 2 equals 0. So I'm writing dot, dot, dot in here to represent that we could have done factoring to get there. We could have split the middle term. In this case, I would have said, well, 5 is clearly not 0. But if x plus 2 equaled 0, then x would equal negative 2. And if x minus 2 equals 0, then x could equal positive 2. Notice you get the same two answers. We took 3 different paths through that problem. They all led to the same answer. So when we have some of these problems, there are options about how we could go about solving them. All right, let's do one last problem. Oh, actually, I'm sorry. We said we were going to do 2 more together. So let's do this one with the decimal. We're going to do this one by solving by square root. So we're going to start by adding 7 to each side. So we have 1.2 q squared equals negative 27. Then we're going to take and divide both sides by 1.2. And I don't know about you, but I'm definitely going to need a calculator to do that. So I'm going to grab my calculator. I'm going to take negative 27 and divide it by 1.2. And I get that q squared is equal to negative 22.5. So then I go to take the square root of both sides. And if this video had a soundtrack, we would hear a record screeching right now because we have an issue. We can't take the square root of a negative number. So we actually stop working at this point and we say that there is no solution. And actually, though, I'm going to back up. We're going to say that there's no real solution. In Algebra 2, you'll learn how to find the actual solution. But in Algebra 1, all we can say for now is that there's no real solution. All right, one last problem to do together because we said we were going to do this one by factoring. So remember, if we're going to solve by factoring, the equation must be set equal to 0. So we're going to start by adding that 49 to both sides. So we have x squared plus 14x plus 49 equals 0. And now we need to split the middle term. So we need 2 numbers that multiply to make 49 and add to make 14. And the first thing that comes to mind is 7 and 7 because not much multiplies to make 49. Luckily, 7 plus 7 equals 14. So we've got x squared plus 7x plus 7x plus 49 equals 0 when we split the middle term. And we know we need to make the sum of 2 binomials. and look at those pairs for GCFs. Well, these have a greatest common factor of x and an extra factor of x and 7 respectively. So we can factor out that x and leave the binomial factor of x plus 7. And then we can look at the 7x and the 49. Those have a GCF of 7 and need the other factor to be x and 7 respectively. So we can factor out a positive 7 and leave an x plus 7 as the binomial factor. When we look at that, we see that they both have an x plus 7 and that they leave behind a second binomial factor also of x plus 7. So when we go to solve this and we're like, well, x plus 7 equals 0 or x plus 7 equals 0, wait a minute, that's the same thing. I don't need to solve the same equation twice. I can just subtract 7 and x is equal to negative 7. That's my one solution to this problem. All right, complete the ones that we starred, take a picture of your work, and upload it into the Google Classroom.